Alright, in this lesson we're going to determine whether lines are parallel or perpendicular. We're also going to decide if the opposite sides of a quadrilateral are parallel based on using the slope formula. So what do we know? We know that parallel lines have slopes that are the same. For example, if one line has a slope of 2/3 and the other line has a slope of 2/3. Exact same slope, that means they are parallel lines. Perpendicular lines have slopes that are what we call the opposite reciprocal. Opposite means the opposite sign, which means -5 or +5, 6 or -6, and reciprocal means flip. So some people say flip. Flip the fraction and switch the sign. So for example, let's say we have a fraction of -4/3, and we need the opposite, and we also need to have the reciprocal. So the opposite makes it positive, the reciprocal flips it upside down, so it's going to be +3/4. So if the slope is -4/3 and the other line has a slope of 3/4 positive, those are going to be perpendicular lines. So to determine if the lines are parallel, perpendicular, or neither, we need to use our slope formula. So the slope is, we subtract our y's, and we divide by the difference of our x's. So again, we have our x and y, x and y. So let's call this line M and this line N. X and y, x and y. Alright, so let's decide if these lines are parallel, perpendicular, or neither. So let's look at line M. Again, I'm going to subtract my y's on top, 3 minus 0. My x's go on the bottom, -5 minus -4. 3 minus 0 is 3. -5 minus -4 is -1. And if I do 3 divided by -1, that's -3. Alright, so that's the slope of that line. Let's look at the slope of line N. Again here, I would subtract my y's on the top, 5 minus -4. And my x's on the bottom, 1 minus 4. If I type 5 minus -4 in the calculator, I get 9. 1 minus 4 gets me -3. And if I do 9 divided by -3, that gets me -3. That means these lines are parallel. P-A-R-A-L L-E, I can't spell, P-A-R-A-L-L-E-L, parallel. These two lines have the same slope, they're parallel. Pair, 2 L's, E-L, there we go. Alright, let's call this line M and line N. So here's my x's and y, x and y, x and y, x and y. Alright, so if I look for line M, I'm going to subtract my y's on the top and my x's on the bottom. So again, my y's go on the top, 4 minus 2, and the x's on the bottom, -5 minus -2. 4 minus 2 is 2, -5 minus -2 is -3, and I can't reduce that anymore. My slope of N, again I subtract my my y's on the top and my x's on the bottom, so 4 minus 3. My x is on the bottom, 3 minus 1. 4 minus 3 is 1, 3 minus 1 is 2. I have a slope of -2/3 and +1/3, or 1/2, that's neither. Now if this was -2/3 and +3/2, that would be perpendicular. But since they're not the same, not the reciprocal, that doesn't work. Alright, line M, line N. X and Y, X and Y, X and Y, x and y. So let's look at line M first. So line M, I subtract my y's on the top, 3 minus 1. I subtract my x's on the bottom, negative 3 minus negative 4. So 3 minus 1 is 2. Negative 3 minus negative 4 is positive 1. 2 divided by 1 is 2. For n, I do my y's on the top, negative 1 minus negative 5. And my x's on the bottom, 3 minus 1. Negative 1 minus negative 5 is positive 4. 3 minus 1 is positive 2. If I reduce that, 4 divided by 2 is 2. These lines are parallel. Now, if you had an example of, let's say, negative 7 over 2 and positive 2 over 7, those would be perpendicular. There's no, let's see, U, P-E-R-P-E-N-D-I-C-U-L-A-R. Alright, so there's no examples of perpendicular. So if we have a negative 7 over 2, positive 2 over 7, again, these are opposite signs, and the fractions are flipped. That would be perpendicular. Alright, so the last direction says, use the slopes to determine whether the opposite sides of a quadrilateral are parallel. So let's draw our quadrilateral here. If we have A, B, C, and D, I'm looking to see if AB is across from DC. So I know that AB is across from CD. AB's here and CD here. If that was a parallelogram, those would be parallel. And also, if AD is across from BC, and that's a parallelogram, AD would be parallel to BC. So we need to see if these two lines are parallel and if these two segments are parallel. So let's test it out. So again, when I have A and B, I use these. Let's go ahead and label our X's and Y's here. When I'm looking for segment AB, I'm going to use points A and B here. So I have my Y's on top, negative 2 minus 2, and then my x is negative 4 minus negative 2. Negative 2 minus 2 is negative 4. Negative 4 minus negative 2 is negative 2. And if I divide that, I get positive 2. CD. Again, I take my y's on the top. Negative 5 minus negative 9. And then my x is on the bottom. That would be negative 4 minus negative 5. So negative 5 minus negative 9 would be positive 4. Negative 4 minus negative 5 is 1. If I do 4 divided by 1, that's 4. We can already tell that this is not a parallelogram because these two sides are not parallel, but let's look at AD and BC. So when I look for AD, I'm looking for A and D. So I'm looking at my y's, negative 2 minus negative 9, and my x's would be negative 4 minus negative 5. So negative 2 minus negative 9 is 7. Negative 4 minus negative 5 is 1. 7 divided by 1 is 7. And again, AD should be parallel to BC if this is a parallelogram. We already proved it wasn't over here. So let's look at BC. Again, y's are in my numerator. 2 minus negative 5. And negative 2 minus negative 4. 2 minus negative 5 is like saying 2 plus 5, which is 7. Negative 2 minus negative 4 is positive 2. And you can't reduce that, it's just 7 over 2. And again, these two would have to be parallel, and these two would have to be parallel in order for this to be a parallelogram. And the answer over here is also a no. So these two sides are not parallel with each other, these two sides are not. So it is not a parallelogram.